It is unfortunate to hear about substandard electrical work. Romex wiring that lacks running boards and other forms of protection is a serious safety hazard. Romex is not designed to be stapled directly to joists without protection. This makes the wire susceptible to damage, and it can create a fire risk. When staples pull out, this indicates that the wiring was not properly secured. The exposed wires could have caused an electrical short or a fire. Electrical work can pass inspection for a few reasons. The inspector may not have been aware of the specific code requirements for running Romex wiring, or the inspector may have simply overlooked the issue. Regardless, the electrical work should be up to the standards. One expectation is that, with the house open to the public for tours, the crew should have been incentivized to do a good job. This would not only reflect well on their reputation, but also ensure the safety of visitors to the house. It is unfortunate that this opportunity was missed. The responsibility for ensuring the safety of the electrical work lies with the electrician who performed the work. The TV show's crew also has a responsibility to ensure that the work they present to the public is of the highest quality. In this situation, it seems that both parties failed to meet their obligations. When installing Romex or non-metallic sheath cable, several important considerations and code requirements must be followed to ensure safety and compliance. Firstly, the National Electrical Code or NEC provides detailed guidelines for the proper installation of Romex. These guidelines cover various aspects of the installation, including how the cable should be supported, protected, and routed. Secondly, Romex must be supported and secured at specific intervals. NEC Section 334.30 generally requires that Romex be supported every 4.5 feet and within 12 inches of boxes, cabinets, and fittings. Approved staples, cable ties, straps, or similar fittings designed and installed so as not to damage the cable can be used. Thirdly, when Romex is run through holes or notches in framing members, it must be protected from nails or screws that could penetrate the cable. NEC Section 300.4 D requires that the cable be protected by a steel plate or bushing at least 1/16 inch thick. This protection is needed when the cable is less than 1.25 inches from the nearest edge of the framing member. Fourthly, Romex should not be installed where it is subject to physical damage. In locations where physical damage is likely, such as in exposed areas of a basement or garage, the cable should be protected by conduit or other approved means. Fifthly, Romex must be protected from abrasion where it passes through metal studs or other metal framing members. NEC Section 300.4 B requires that the cable be protected by bushings or grommets to prevent damage to the cable insulation. Sixthly, when Romex is installed in accessible attics or crawl spaces, it must be protected according to NEC Section 320.23. In accessible attics, Romex must be protected by guard strips when run across the top of floor joists, or when run within 7 feet of the floor or floor joists across the face of rafters or studding. Seventhly, Romex should be derated if it runs through insulation, which is required by NEC Section 310.15. The ampacity of the cable must be reduced to account for the insulating effect of the thermal insulation, which can cause the cable to overheat. Eighthly, Romex should be kept away from heat sources such as recessed lighting fixtures and chimneys. Heat can damage the cable insulation and create a fire hazard. Ninthly, Romex should be installed in a neat and workmanlike manner. This means that the cable should be run in a straight and orderly fashion, and that all connections should be made properly and securely. Tenthly, all electrical work should comply with local building codes and be inspected by a qualified electrical inspector. Local codes may have additional requirements for Romex installations that are not covered by the NEC. Some other best practices include avoiding running Romex in damp or wet locations. Romex is not suitable for use in wet or damp locations, such as outdoors or in bathrooms. Use appropriate cable connectors when connecting Romex to electrical boxes or fittings. Use connectors that are designed for use with Romex and make sure that they are properly tightened. Avoid over-tightening staples or cable ties, which can damage the cable insulation. Staples and cable ties should be snug, but not so tight that they compress the cable. When running Romex parallel to framing members, maintain a consistent distance from the edge of the framing member. This will help to ensure that the cable is not damaged by nails or screws. Clearly label all Romex circuits in the electrical panel. This will make it easier to identify circuits in the future and prevent accidental overloading. Here are some additional details about running boards and conduit. Running boards are horizontal boards attached to the underside of joists or rafters, used to support and protect Romex wiring. Conduit is a metal or plastic pipe used to enclose and protect electrical wiring. They each have different uses and requirements. Firstly, running boards are typically used in exposed locations where the wiring is subject to physical damage. They provide a solid surface to which the wiring can be stapled or secured, protecting it from impact and abrasion. Secondly, running boards are often used in basements, crawl spaces, and attics where the wiring is exposed to the elements. They help to keep the wiring dry and prevent it from being damaged by moisture. Thirdly, running boards are typically made of wood, but they can also be made of metal or plastic. The material used should be durable and able to withstand the environmental conditions to which it will be exposed. Fourthly, when installing running boards, it is important to ensure that they are securely attached to the joists or rafters. The board should be wide enough to accommodate the wiring and should be spaced closely enough to provide adequate support. Fifthly, conduit is typically used in locations where the wiring needs to be protected from physical damage, moisture, or other environmental factors. It provides a rigid enclosure that protects the wiring from impact, abrasion, and corrosion. Sixthly, conduit is often used in underground installations, in industrial settings, and in areas where there is a risk of explosion or fire. It can be made of metal, plastic, or fiberglass. Seventhly, when installing conduit, it is important to use the correct type and size for the application. The conduit should be properly supported and secured, and all connections should be made according to the manufacturer's instructions. Eighthly, NEC Section 334.15 states Romex must be protected from physical damage where necessary by conduit, electrical metallic tubing, Schedule 80 polyvinyl chloride conduit, or other approved means. This section does not explicitly mandate running boards, but they can be a means of providing protection. Ninthly, NEC Section 300.4 D addresses protection against physical damage. It requires cables to be protected where subject to physical damage. While running boards can offer protection, they must be installed correctly to meet this requirement. Tenthly, local electrical codes may have specific requirements for the installation of Romex wiring, including the use of running boards or conduit. It is important to check with the local building department to ensure that all installations comply with these requirements. Here is some information on how to properly secure Romex wiring. Proper stapling is crucial for securing Romex wiring. Firstly, use listed staples specifically designed for Romex or non-metallic sheaths cable. These staples have rounded edges to prevent damage to the cable's outer jacket. Secondly, staples should be applied with a staple gun or hammer, ensuring they are driven straight and flush against the wood. Avoid angling the staples, as this can damage the cable. Thirdly, follow NEC Section 334.30, which requires Romex to be supported every 4.5 feet and within 12 inches of boxes, cabinets, and fittings. This ensures the cable is securely held in place. Fourthly, when stapling, make sure the staple straddles the cable without compressing it. Over-tightening can damage the insulation, while loose staples won't provide adequate support. Fifthly, ensure that the staples are not driven too deeply into the wood, as this can also damage the cable. The staple should hold the cable firmly without penetrating the outer jacket. Sixthly, avoid stapling Romex in areas where it may be subject to physical damage or abrasion. If such areas are unavoidable, provide additional protections such as running boards or conduit. Seventhly, when running Romex horizontally across joists or studs, staple it to the underside of the framing member. This provides better support and protection compared to stapling it to the side. Eighthly, inspect the stapled Romex regularly to ensure the staples remain secure and haven't loosened over time. If staples are loose or damaged, replace them immediately. Ninthly, consider using cable ties or straps instead of staples in certain situations. These can be particularly useful when securing Romex to irregular surfaces or in areas where stapling is difficult. Tenthly, always adhere to local electrical codes and regulations regarding Romex stapling. Local codes may have specific requirements for staple spacing, type, and installation methods. Electrical inspectors are responsible for ensuring that electrical installations comply with the NEC and local electrical codes. The inspections can be general or specific. Firstly, electrical inspectors review electrical plans and specifications to ensure that the proposed work complies with the NEC and local codes. This includes verifying that the wiring methods, circuit sizes, and overcurrent protection devices are appropriate for the intended use. Secondly, electrical inspectors conduct on-site inspections of electrical work to ensure that it is installed in accordance with the approved plans and specifications. This includes verifying that the wiring is properly supported, that all connections are made correctly, and that all equipment is properly grounded. Thirdly, electrical inspectors verify that all electrical equipment and materials used in the installation are listed and labeled by a recognized testing laboratory such as Underwriters Laboratories or UL. This ensures that the equipment and materials meet safety standards. Fourthly, electrical inspectors conduct tests to verify the electrical system's integrity. This includes testing for proper grounding, continuity, and insulation resistance. Fifthly, electrical inspectors issue permits for electrical work and may also issue certificates of compliance upon completion of the work. These documents indicate that the electrical installation has been inspected and found to comply with the applicable codes and standards. Sixthly, inspectors may focus on specific areas of concern. For example, they may pay close attention to the wiring in kitchens and bathrooms, where there is a high risk of electrical shock. Seventhly, inspectors will check the grounding system to ensure it is properly installed and connected. This includes verifying the grounding electrode conductor's size and the grounding connection's integrity. Eighthly, inspectors will verify that all electrical boxes are properly sized and installed. They will also check to ensure that all box fill requirements are met, meaning that the box is not overcrowded with wires. Ninthly, inspectors will check the overcurrent protection devices, such as circuit breakers and fuses, to ensure they are correctly sized and installed. They will also verify that the overcurrent protection devices are properly labeled. Tenthly, inspectors may conduct a final inspection after the electrical work is completed to ensure that everything is in working order. This may include testing the operation of lights, receptacles, and appliances. When problems are found, there can be different outcomes. Firstly, if an electrical inspector finds violations of the NEC or local electrical codes, they will typically issue a notice of violation to the property owner or contractor. The notice of violation will describe the violations and provide a deadline for correcting them. Secondly, the property owner or contractor must correct the violations within the specified time frame. This may involve making repairs, replacing defective equipment, or redoing the electrical work. Thirdly, after the violations have been corrected, the property owner or contractor must request a re-inspection from the electrical inspector. The inspector will then return to the property to verify that the violations have been corrected. Fourthly, if the electrical inspector determines that the violations have been corrected, they will issue a certificate of compliance or sign off on the permit. This indicates that the electrical installation now complies with the applicable codes and standards. Fifthly, failure to correct electrical code violations can result in penalties such as fines or legal action. In some cases, the electrical inspector may order the electrical service to be disconnected until the violations are corrected. Sixthly, the inspector has the authority to reject the installation if it does not meet code requirement. This means the electrician must redo the work until it passes inspection. Seventhly, in some cases, the inspector may require additional documentation or testing to ensure compliance. This could include providing load calculations or conducting insulation resistance tests. Eighthly, if there is a dispute between the electrician and the inspector, there is typically an appeals process. The electrician can appeal the inspector's decision to a higher authority, such as a local electrical board. Ninthly, the inspector will document all findings and actions taken during the inspection process. This documentation is important for tracking compliance and providing a record of the inspection. Tenthly, it is important to communicate with the electrical inspector and address any concerns or questions they may have. Working cooperatively with the inspector can help to ensure that the electrical installation is safe and code compliant. Here is some information on common electrical code violations. Firstly, exposed or damaged wiring is a common violation. Wires must be properly enclosed in conduit or cable assemblies. Damaged insulation or exposed conductors pose a shock and fire hazard. Secondly, overloaded circuits occur when too many devices are connected to a single circuit, exceeding its capacity. This can cause the circuit breaker to trip frequently and can also lead to overheating and fire. Thirdly, improper grounding is a critical safety issue. Grounding ensures that electrical faults are safely diverted to the ground, preventing shocks. Missing or inadequate grounding is a common violation. Fourthly, the NEC specifies the minimum size of conductors for different applications. Using undersized wires can lead to overheating and voltage drop. Fifthly, junction boxes must be accessible and have covers. Open or inaccessible junction boxes are a violation and pose a safety hazard. Sixthly, all electrical components must be listed and labeled by a recognized testing laboratory. Using unapproved or counterfeit components is a violation. Seventhly, electrical panels must be properly labeled, indicating the circuits served by each breaker. Unlabeled or mislabeled panels can make it difficult to identify circuits in an emergency. Eighthly, outdoor electrical equipment must be weatherproof and protected from the elements. Using indoor equipment outdoors is a violation and can lead to corrosion and electrical failure. Ninthly, temporary wiring must be installed in accordance with the NEC. Improper temporary wiring is a common violation on construction sites and can pose a significant safety hazard. Tenthly, modifications or alterations to electrical systems must be performed by qualified electricians and must comply with the NEC. Unauthorized or improper modifications are a violation. Here is some general information about electrical safety. Firstly, always turn off the power at the circuit breaker before working on any electrical circuit. This will help to prevent electrical shock. Secondly, use insulated tools when working on electrical circuits. This will help to protect you from electrical shock. Thirdly, never work on electrical circuits in wet or damp conditions. Water is a good conductor of electricity, so working in wet conditions can increase your risk of electrical shock. Fourthly, if you are not comfortable working on electrical circuits, hire a qualified electrician. Electricity is dangerous, so it is important to have a qualified professional do the work if you are not comfortable doing it yourself. Fifthly, test all electrical outlets and circuits regularly to make sure they are working properly. This will help to identify potential problems before they become serious. Sixthly, replace any damaged or frayed electrical cords immediately. Damaged cords can pose a fire hazard. Seventhly, never overload electrical outlets or circuits. Overloading can cause the circuit breaker to trip or can even start a fire. Eighthly, keep electrical appliances away from water. Water and electricity do not mix, so it is important to keep electrical appliances away from water. Ninthly, teach children about electrical safety. Children need to know the dangers of electricity and how to avoid them. Tenthly, have your electrical system inspected by a qualified electrician regularly. This will help to identify any potential problems and ensure that your electrical system is safe. Also, ground fault circuit interrupters or GFCIs are life-saving devices that protect against electrical shock. They should be installed in all wet locations, such as bathrooms, kitchens, and outdoor areas. Arc fault circuit interrupters or offsides are devices that protect against electrical fires. They should be installed in all bedrooms and living areas. Smoke detectors are essential safety devices that can save lives in the event of a fire. They should be installed on every level of your home and tested regularly. Carbon monoxide detectors are also important safety devices that can protect against carbon monoxide poisoning. They should be installed on every level of your home and tested regularly. Finally, develop an emergency plan in case of a fire or other electrical emergency. This plan should include escape routes, meeting places, and contact information for emergency services.